Hello, in this video we're going to give a brief overview of our data warehouse project for an airline's flight operations. The airline already has a normal operational system for ticket sales and daily updates, but this system can't answer deeper analytical questions. So our goal was to build a separate analytical warehouse that can help the company understand things like road profitability, delays, seasonal trade, and aircraft performance.
So task two was the largest and the most technical part of the project. The first thing we did was to create a set of staging tables, which represent the operational system. We filled them with realistic sample data, just like airports, routes, aircraft, flights, passengers, and tickets. And these are the raw inputs for our ETL process. After setting up the staging area, we created the main dimensions for our analytical schema. One of them stores calendar information for the entire year, and another one contains all route details, including both the origin and destination airports. We also have a dimension which tracks aircraft configurations over time. This one behaves like a slowly changing dimension, meaning every time an aircraft seating configuration changes, a new historical version is recorded. Finally, we created a small dimension for grouping flight departures into morning, afternoon, evening, and night categories. Our fact structure brings everything together at the level of a single completed flight. This is where we store all the key performance metrics, just like tickets sold, revenue, estimated fuel cost, profits, load factor, delays, and so on. And the core of task two is the ETL procedure we wrote. It loads the calendar dimension for the whole year, builds route information by joining airports with route records, creates historical aircraft entries, and assigns each flight to a time of day category, and also calculates all the metrics needed for the fact data. We also use two PLSQL functions inside the ETL. One of them estimates fuel cost based on aircraft model and distance, and the other one converts numeric delays into categories just like early or on time.
For task 3, we were asked to demonstrate advanced analytical SQL. Instead of explaining all of them, we will focus on just the one example, the roll-up query. The business question it answers is how much revenue and profit do we make by road, quarter, and year, and what are the overall totals? Rollup helps us calculate these different levels in a single query. It starts by giving detailed results for each row inside each quarter. Then it automatically generates subtotal rows for the quarter and another subtotal for the whole year, and finally one grand total for everything. This type of query is helpful because analysts often want to see numbers at different levels of detail without writing separate queries for each level.
For task four, instead of covering everything, we will focus on one important feature, which is the monthly aggregate structure we created for dashboard performance. The idea is actually very simple. Instead of running heavy calculations on all individual flights every time someone's open a dashboard, we pre-calculate monthly totals for each route. These totals include the number of flights, total revenue, profits, average load factor, average delay, and on-time percentage. We also wrote a procedure which refreshes these monthly summaries. When we compared performance, queries using this pre-aggregated data were much faster than queries that had to read all the detailed flight rows.
In summary, we designed a schema warehouse, implemented a full ETL workflow, built an analytical SQL, and optimized the reporting with aggregated monthly data. Together, these steps from a complete and realistic airline analytics solution. Thank you for watching.